And welcome everybody to a lesson on percent of error. We've been talking about percentages for a while. Now we're going to talk about, hey, how far were you off? Was it a big deal? Was it a small deal? Now I will point out this is not really a lesson in the textbook, so you will not have that to aid you. So it's important to take notes as I invite you to take notes. We'll put notes up on Cami. I'll hand out paper notes if you wish. And we'll go from there. Go ahead and pause for a second. Take a look at your answers. Come on back when you're ready. And again, our focus, let's say, since we've been learning about percentages for a while, and we would set up a ratio equal to another ratio. This is percent of change. We always put the original amount from 90 to 100, goes up 10, and now we can find the percent that it changes. Here we're not looking so much for change. We're looking for how far were we off. For instance, let's say you guessed you'd get a 95%, you really get an 88%. Once again, we're looking for the percent. The only question is how to fill these pieces in. And you will continue to look at things in statistics, research, where it matters how far you're off. So that's our goal. Today's objective, I will find a percent of error. Now, first thing for your notes, what is percentage error? Percentage error is a measure of how inaccurate an approximation is. Now, approximation, fancy word for guess. That is always compared to the exact value. So just as before we were looking at percentage of change, we compared the percent to 100 always. And then we always cared about the original and looked at the change. In other words, how much did it increase? How much did it decrease? Now you're going to see some slight similarities and differences when you're looking for percentage error. It will not surprise you that we're going to put percent compared to 100. But instead of original, we're going to look at the number that we care about. In other words, the exact number. And what do we put in the numerator? We're going to subtract the approximate amount from the exact amount. Now, one thing I'll say here, I'm surprised the other teacher didn't say it. These bars mean absolute value. Let's say your number was too small. If you subtract something, you're going to get a negative. But we don't really worry about negatives. We'll say that our percentage error was such and such percent too high or such and such percent too low. So when you're looking for absolute value, you just take the distance away from zero. In other words, you make sure it's positive. Let me just give you an example here, all right? Now, in class, we'll do a bunch of these and we'll have students make some guesses. I looked at Oprah and I thought, maybe she's 65. I didn't know if she was older than my parents or not. Excuse me, I guessed 65. But it turns out that her actual age was pretty close, not bad. So now how do we set up and find the percentage of error? Well, naturally, if we want to know the percent of error, P is the missing piece. What is the exact number? Why do I keep going? I feel like I always look at that denominator first. Now to find the number that goes up top, we will subtract the approximate from the exact. And please notice here, it's a change or a difference of -2. Well, forget that. Let's just say I am 2 away from where it should be. Now from here, folks, you know what to do. Now it's just solving a proportion. Let me get a different color for that so I'm a little more clear. So let's go ahead and do our cross products. 2 times 100, 67 times P. I don't know what 67 times P is. I know what 2 times 100 is. We'll go ahead and divide by 67. And it turns out this guy is going to need to be rounded. Now I believe you guys trust me with my division skills. 28, and it's really close. Let's go to the nearest tenth of a percent. So that is my percentage of error. Oh my goodness, Mr. Cowan, that does not make sense. That's because I typed in the wrong number in the calculator. Calculators are great, but they only do what they are told to do. So let me try to erase that without ruining all the work. There we go. And so we go back Now let's type in the proper number, shall we? 200 divided by 67. Whoa, 2.9850, and of course it goes on forever, but if I'm rounding to the nearest tenth, is that closer to 2.9 or 3.0? It's 3.0, and because I'm rounding to the tenth, I need to put that zero there to show them, because otherwise it makes it look like, if I just put this, it makes it look like I rounded to the nearest whole. So it's not wrong, it's just best to put that tens place. Once again, the exact number goes in the denominator, and the difference between your guess and the exact number, taking its absolute value, that's what goes into the numerator. Let me do a couple more, folks. I think this will help. Mickey Mouse. This one, I guessed too high. So for Mickey Mouse, I don't know why, but I guessed 100. Looked it up on the internet. Turns out he is 93 years old. Originally came out in 1928. Okay, so how do we set this up? Remember, the question is asking for the percent. That's the unknown. The exact age is 93. Now, how far was I away? I'm going to go ahead and subtract my approximation from the exact number. 100 minus 93 is 7. And of course, what's the absolute value of 7? That doesn't change, right? So now I have the proportion set up. Let's go ahead, find our cross products. 93 times p is 93p. 100 times 7, 700. Go ahead and divide by, oh, don't do disappearing ink on me. Just one of those days, folks, just one of those days. All right, let's go back. This might be a little thicker than I'd like, but I'm going to have to deal with it. 93 p's equals 700. Divide by 93 from both sides. And as long as we type things in, I'm going to guess it's going to be an approximation. Let's go ahead and find out. 700 divided by 93, trust my division, please. Very close to 7 5/10%, which is really not too far away. In fact, well, 3% was a better guess. I was closer on Oprah than I was on Mickey Mouse. Let's do one more. I'm just going to pick Barack Obama. If I had to do this again, I would pick the current president, just to keep things up to date, but I don't have those numbers for you. So Barack Obama it is, I guess, 64, real age 59, born in 1961. So let's go ahead now and let's check. We are looking for the percent of error. His exact age is 59. How far were we away? Let's go ahead and approximate. Taking the absolute value, 64 minus 59 is 5. Absolute value of 5 is 5. You know what? I'm going to change the problem a little bit, and I'm going to act like I underestimated, just to make sure that's abundantly clear. Because now it looks like I'm -9 away. But remember, we don't need to worry about increase, decrease, above or below. So let's take the absolute value of 9. And now let's go ahead and solve. 59 times p, 59 p's. 100 times 9, 900. But let's solve for p and divide both sides by 59. And p, again, trust my division, 900 divided by 59. That one was not so close, was it? 15 3/10%, my worst guess yet. But I wanted to very much emphasize, if you look at the blue, didn't really have to worry about absolute value because my guess was larger than my actual age. But please, when you get to problems like this one, if you underguess, if your guess is below the exact number, do not put a negative in there. It's okay, you can say you're 15% above, you're 15% below, but don't worry about negatives. So that's what we got, folks. Homework coming at you will be a worksheet. I had some more people from pop culture the last decade or so. Percentage error and percent increase, to remind you. Yeah, I think I'm going to do one more problem with you, just to make sure we're good with this. So take a look at number 9. Krista buys an alarm clock, $45. Whoops, let's go back. Try not to move it. Store increases, I'm going to draw a little arrow just to remind myself that, by 150%. Question is, what is the new price? Now I want you to think about that. Here's the price, $45. We don't just increase one whole of these and put it on top. We increase a whole and a half. In other words, 150% higher. So perhaps you want to make a guess at that point. All right, 150%. The original or total price of the alarm was 45. Let's find the new thing. In this case, now we can go ahead with our cross products. 100 times n is 100n. 150 times 45 is 6,750. But let's find out what n is, shall we? So now what we do is we move that decimal place 2 to the left. Now remember, folks, that is the increase. So that's not the final cost. It went up after starting at 45. So now that we know the increase, let's go ahead and add those together, and we will find that the final cost of that alarm clock is not 45, is not 67, but it's put those two together. It's $112.50. So I just wanted to do one more example just to show you what an increase or percentage percent increase would look like. And that's what I got, folks. Take time, do well, and let's grow.